thank you all for joining us, our Red Alert LEA workshop. The event's supposed to be actually face-to-face, but due to the current situation, it can't take place in the real world. We will do it, unfortunately, in the virtual one. I'm not sure that unfortunately is the right term, because instead of small event with people from the area only, we have many with us now, and not less important, people from all over the world. We have with us, I can see, from the US, Brazil, Israel, Argentina, South Africa, Madagascar, China, India, and obviously from European countries, Germany, Bosnia, Czech Republic, Spain, and more. I see that we have also many participants from law enforcement agencies, from security ministries, from the private sector, the industry, from universities, and even few students. That's good. So welcome everybody, and I hope you will enjoy listening to us. The event will take place about 1 hour. We will start with introduction from Dr. Monica Florea, which is the coordinator of Red Alert Project. Then I will talk about the threat of terrorism in both the real and the cyber world. Jennifer from Insikt Intelligence will talk about the technological response. And Yaniv from the Israeli National Police will elaborate on the police use of technological tool. Then we will open the floor for questions. And after that, for those of you that are interested, we will have a demo of the Red Alert tool. So thank you again for joining us. And Monica, the floor is yours.
So again, hello everybody. Welcome to our project webinar. I will make you a very short presentation of Red Alert project. I'd like just to present a little bit myself. So I'm the project coordinator. I'm Monica Florea. I'm the head of unit of European projects in software imagination and vision onshore Simavi, a large company, a software company located in Bucharest in Romania. A brief description of our project. Red Alert, it's a Horizon project. It's a research and innovation action. The name, the title of the project is Real-Time Early Detection and Alert Systems for Online Terrorist Content based on natural language processing, social network analysis, artificial intelligence, and complex event processing. The title is quite comprehensive, revealing also the objective of the project. The project started on 1st of June 2017, and it will end end of September this year. The budget is the total budget of the project. It's around 5 million euros, and the project objectives, on short, are the following. First of all, the project it's meant to. It's meant to provide a complete toolkit for law enforcement agencies in order to collect, process, visualize, and store data related to terrorist group, whether related to propaganda, fundraising, recruitment, mobilization, data manipulation, and misinformation. The project, it's covering a wide range of social media channels, in particular new targeted channels, which are increasingly used by terrorist groups in order to disseminate their content. Channels like Facebook, Instagram, Twitter, YouTube, etc. We support different languages like English, French, Spanish, Arabic, Russian, German, Romanian, Hebrew, Turkish, etc. And what is important, the toolkit will allow LEAs to take coordinated action in real time while preserving the privacy of the citizen. The project is a research and innovation action again. So The project aim is to combine artificial intelligence methods with social network analysis and natural language processing technologies in order to detect anomalies in content production, content nature, content spread, in order to provide early detection of terrorist activities. The input from all these artificial intelligence, social network, and NLP technologies will be fed into a complex event processing engine in order to predict potential threats areas based on content production patterns, allowing in this way LEAs to analyze, monitor, or take action on online terrorist content. A brief presentation of our consortium, project consortium. We are 15 partners from 7 countries, and we cover a wide range of organization type. As a CIMAVI, we are an industrial partner, so a large software company. We have also a regulatory association, Malta Information Technology Law Association, MITLA. We have also a very important 5 law enforcement agencies that are partnered in the project. This Guardia Civil from Spain, Israel National Police, Metropolitan Police Service from UK, SO15. We have also Protection and Guard Service from Romania and also from Republic of Moldavia. We have also 4 SMEs, Innovation Champions, Interview, Insikt, Maven, but also ICT. And we have research and academic organizations that contribute with the research part of the project. The Counter Terrorism ICT Institute from Israel, ELTE from Hungary, City University of London, but also Birmingham City University from UK. In the project, we are covering 5 pilots. One pilot it's coordinated by, it's implemented by SO15 from UK. Another pilot it's implemented in Spain by Guardia Civil. One pilot is implemented by Guard and Protection Service in Romania. The 4th one it's delivered by Protection and Guard Service in Republic of Moldavia. And also we have a pilot implemented by Israel National Police. What is important in Red Alert project and in this type of project is to cover and to protect the privacy of citizens. So processing of personal data within a law enforcement context brings with it a number of regulatory challenges. And therefore, we have a partner dedicated to this. It's MITLA from Malta. It's an IT law association that help us with all these privacy issues. This was a very short presentation of the project, and I would like to give the floor to Uri now in order to pass to the next point of our presentation. Thank you very much.
So my talk will be about the threat of terrorism. I will start with the threat in the physical world and the response to it, and then about the threat in the cyber world and the different response that we need. So as we can see, terrorists are very innovative groups, challenging us day after day, while we need to find the right response. Few examples. One of them is Richard Ray, a British guy with ties to Al-Qaeda, was caught on 2001 on an American airline flight from Paris to Miami with IED hidden in his shoes. And the response since then, most of us in most of the airport need to take down our shoes in order to be screened. Another example, 2006, Al-Qaeda planned to carry out simultaneous attacks on a Canadian and American planes traveling from London to the US by smuggling liquid explosive and soda bottles. Response: since then, we are not allowed to board with more than 100 cc. But unfortunately, not always it works. 2015, we had the Russian airplane depart from an Egyptian airport in Sinai to St. Petersburg, Russia. The airplane crashed after the explosion of a bomb that was hidden in a soda can. All 224 passengers and crew members that were on board died. And then 2009, the Omar Farouk, the underpants bomber, Nigerian guy, attempted to detonate plastic explosive hidden in his underwear while on board of Northwest airplane flight from Amsterdam to Detroit, Michigan on Christmas Day. And since then, we are being screening in airports every time. So not all of us are happy with those procedures. Some of us might become frustrated. And this is one of the examples of a guy that went through the machine once and again, and finally find a solution in order the machine not to beep. This is one of the Russian airports. So this is a frustrated guy, and you see now everything is fine. He can continue, right? Let's see another example. This video is from a Pakistani airport. The man is new to the X-ray procedures, didn't really know what he's supposed to do. And you can see that he's getting a guidance from the security guy. He's telling him where he needs to put the things. And in a minute, you will see the bag coming out of the screening machine. But as you see, not alone, together with the guy. Now, check the security guy, what he's doing. Okay. So we might not be happy when somebody we don't know is touching us. We might hate the idea that our dirty laundry shows in public. I'm not sure also if this guy, like the procedure he had to follow in Poland. This is Justin Bieber, if you can recognize him. So terrorist evolution in terrorism in the cyber world is just the same like in the Western world and the entire world. Starting with websites, then interactive tools like forums, chat rooms, and then digital magazines. And finally, the two last innovative parts are social media and dark web. We won't talk much about the social media. I suppose that most of us are familiar with it, but we need to understand that the threat of social media is that terrorists are penetrating into our most intimate place, in our bedrooms, with no doors, no gates, no borders in between. A little bit about the darknet, because some of us maybe are not familiar with it. So you can actually purchase whatever you need in the darknet. You can buy illicit drugs, guns, ammunition, fake bills, fake documents, cyber attack tools. What you need is only a software that you may find everywhere, almost everywhere. So let me share with you some highlights from this space. You want to buy a gun? Black market is your place. You want to compare different prices and qualities? Please do. Are you interested in a fake passport? Passports are not so much in use currently, definitely in Israel, but let's hope that it will be in use soon. Here you can see two quality fake passports discovered a few months ago on Iranian couple traveled in Ecuador. In the upper side, you can see the original Iranian passport, and below them, the fake Israeli ones. Those passports, the Israeli ones, were faked by a professional guy in a good quality. Not like this one, also fake Israeli passport, but many mistakes inside. The red circles are the typing mistakes. If you want to buy counterfeit notes, this is the place. You can buy 5 fake notes of 100 each in 250 only. You're getting 50% discount. Or 10 notes of 100 each in 450 only. Or 2,000 in 750 only. So you can see that the regular sense of business is applicable also here in the darknet. Buy more, get it cheaper. Drugs, if you need, both narcotic and medications. By the way, doctors' prescriptions is not really necessary in this case. And here you can see we divided actually the terrorism use of internet into 10 categories. You can divide it in a different way, but the idea is that terrorists are using the cyberspace for everything from A to Z. And this is what we are facing. So in our case, the traditional war against terrorism, the one we are used from the physical world, isn't enough anymore. We need something new. The only way we can fight terrorism is with good intelligence, to know their intention before they execute their plans, to know what are they planning in advance. It's not that intelligence wasn't important before, but in order to fight terrorism in the cyber world, good intelligence based on big data analysis is a must. And this is the place where Red Alert is coming into the picture. Red Alert combines artificial intelligence technologies to collect, process, visualize, and store online data related to terrorists. I won't take Jennifer part, and I won't talk about the technological issues, not because I'm a nice guy, just because I'm not smart enough. But with your permission, a few words about the challenges in the eyes of the intelligence guy, the one that's supposed to do the analysis. So obviously, we still don't have common definition of terrorism, but I won't enter into it now. We talked already about the innovative technology that terrorists are using. So let's talk a bit about the challenges that we are facing in identifying between terrorist content and a legitimate one. Few examples. You can see a shooter video game. I suppose that most of you are familiar with it. If not you, at least your children. The name is Call of Duty. This is the banner. And this is ISIS modification for Call of Duty. Banner for propaganda and recruitment. This example, the last scene, the killer caught by police after manipulating them to arrive to location where he pre-delivered decapitated head in a box. This is 7 film, and this is James Foley execution 2014, by ISIS. This is Mr. Robot, the original American trailer that was introduced first in 2015. And quite similar, we can see Cybernetic Digital Terrorist Cyber Warfare magazine in a German language using it. On the left side, you can see a recruitment to the German army. Very, very similar to the one on the right side, but on the right side is a jihadist campaign of recruitment. And here we have the minions, the original banner, and the one used by terrorists. Interesting, trying to concentrate. One here. that you might have a problem to guess which terror organization is the one that using it for propaganda. And the reason it's not a real terror organization is Polo, Volkswagen, using terrorists as propaganda for their own advertisement. So obviously we have false positive, false negative, we have language problem, mixed Arabic characteristics with Arabic and English one. We have Tawhid. Here we can know that if it's terrorist or not, but in this case, we don't know until we can see the flag. And here we don't know until we see the guy with his nephew. And false positive, on one side, terrorist propaganda. On the other side, you can see CNN or even my colleague, Stevie Weinberg from ICT. The last challenge I will talk about is the privacy, the GDPR. Huge challenge. Few things about it. Let's talk about the democratic dilemma in counterterrorism. What you can see now is the responsibility of states to protect the citizens' security. How can they do it? They need to provide the law enforcement agencies with counterterrorism tools, intelligence gathering, deterrence, prevention tools, etc., etc. Here on the right side, you can see that the state also has responsibility to protect our human rights, our privacy, freedom of speech, access to information, freedom of practicing religion, equality under the law, etc., etc. And the question mark is very, very small. We need to decide where to put the balance. Different states are willing to sacrifice different values. And this is actually the main problem in order to have international cooperation. This is also the problem of countries to comply with the GDPR, because not all the states are putting the balance in the same place. And I would like to conclude with a picture that was taken in Morocco. I don't know if you can see it clearly, but here we can see geese are climbing on trees in Morocco. The reason is simple. They don't have enough food on the land. So they learn how to climb the trees. They understood that they need to climb the trees in order to eat. This is what we need to do, our leaders, but ourselves. We need to understand that we need to change the balance, the existing one, if we want to stop the terrorism from using the cyber world. Thank you very much. And now we will continue with Jennifer.
Hi, I'm Jennifer. I'm going to share my screen with you. Just one moment, please. Can you see that?
Yes.
Oh, okay. I'm going to put it in play version just a second. My name is Jennifer Woodard. I'm the CEO and co-founder of Insikt Intelligence and a proud partner of the Red Alert Project. So let's get started with our presentation. Just one moment.
You can do F5. It will put you on presentation.
Okay. Hold on just a second.
Perfect.
There we go. Okay. All right. So thank you for welcoming me, Yuri, to the seminar today. As I mentioned, my name is Jennifer Woodard, and I'm a co-founder of Insikt Intelligence, and we're a project partner in the Red Alert Project. We want to talk a little bit today about the intelligence challenges for detecting terrorist and radical content online. And basically the challenges that we faced in Red Alert and how we kind of overcome those. In terms of who we are, just very quickly, we're experts in AI for law enforcement. We do detection of radical content, all sorts of criminal content online via SaaS, via data analysis services, software, and we also train LEAs in AI and data science topics. So there are lots of technical challenges in detecting radical content on the internet, as you might imagine. We're going to get into those kind of in detail, more from the perspective of what it means in terms of some of the issues that Ori was touching on, for instance, language. We are focusing the presentation on those challenges because that's kind of where our expertise is, but the project itself covers lots of different areas beyond just language challenges. I'll get into some of those as well. So just to kind of, get started, as a tech company dedicated to kind of the detection of criminal content online, we know a couple of things about the challenges. And one thing that I think is kind of a simple truth is that most tools that are out there don't really work. That sounds kind of, it's kind of a brash comment, but, they tend to give false positives. They kind of miss important evidence, and they don't work because they're not humans, and sometimes they don't work because they don't have AI incorporated, but above all, they don't work because they're not investigators. And when they do, they have a hard time working well due to the challenges that we're kind of covering here today. So, a few examples. If you look at this content here, I think it's pretty clear that you could see that it's radical content, right? There's lots of kind of keywords and buzzwords that you would see from radical types of users on the internet, that it would be easy to kind of, for AI or even non-AI keyword searching types of tools to pick out. This as well, this would be a kind of radical content that it would be really, really easy for, AI tools to pick out, because the type of images that it's showing, the type of language that it's using is pretty obvious, right? But then you look at something like this, and would you say that this is radical content? They look a little aggressive, but I wouldn't say that they're necessarily radical, but actually it is. This is actually a game where radical content has been found. Now let's look at these examples of, some of these statements. You see statements like France, you reap what you sow. Anonymous writes scripts and bots that can report your account to Twitter and get you suspended. You could do the same thing to them using Python. The epic story of a righteous couple whose love for Allah was greater than the love they shared between themselves. So these sentences unto themselves, do they seem radical to you? Well, they are. The thing is, you can see right here in the context of this first sentence that it is actually radical content, but individually it is a piece of content that would have not been picked up by a traditional AI tool as a radical piece of content. Same with this. The hashtag is related to the San Bernardino terrorists. And same with this. So none of these examples that I'm showing you here would have been picked up by traditional AI tools. They're flagged as neutral. Lots of tools will be looking for things like positive and negative sentiments and very basic kind of semantic features. And this particular content would not have been flagged. So as you can see, there's lots of challenges in terms of what can be detected by AI for intelligence purposes. These are very much related to language, and there are other ones as well. Some are still related to language. For instance, not specifically related to the text itself, the actual way things are necessarily written, but we also know that the way language is used changes. So, the changing dynamics of language makes it difficult for AI to understand what is radical and what isn't radical. This is just one example of, a word that comes from a certain type of a movement that is later turned into, teen internet slang. And the content related to that is no longer applicable to its original meaning. Or you have examples like this, for instance, where, if you look on a timeline of the way certain types of internet slang has been used from 2005 to 2016. It's completely different. You have some examples here on the left side, which basically are things that a traditional AI wouldn't be able to pick up. And as already mentioned, you also have the challenge of kind of multilingual content. You have people mixing languages together, Spanglish, people were using French with Arabic. So all of these things are really, really hard to model for. And AI models, basically, they need to be kind of fed with this new information in order to keep up. So basically, you don't want AI to be like this mom, right? She doesn't know what any of these acronyms mean. You want the AI to be more like a teenager who's kind of in the know of everything and very up to date on the lingo. So another challenge is that, you know, with the new kind of propaganda and tailored recruitment methods, I'm sure ICT could speak to this, you know, it's not about just putting out some kind of blanket propaganda for everybody on the internet to see. Lots of radicalization efforts are done very locally. So as they're done locally, they're geared towards local communities, and beyond just the language, there are kind of cultural things, cultural aspects to take into consideration. Cultural memes, things like that, that, you know, a typical AI that's trained just for the quote unquote terrorism domain would not be able to detect. And then beyond language, I wanted to point out that the Red Alert Project, I'll talk a little bit about kind of how this works later, but the Red Alert Project goes beyond kind of just detecting language related pieces of content or nuances. We also go beyond with using what we call, you know, network analysis, which is understanding kind of the communities online. And that's a big challenge for law enforcement. So if you're looking at a bunch of pieces of content from multiple users who are retweeting and tweeting and, you know, mentioning, it gets really big really quickly. And it's hard to visualize this, and it's hard to kind of understand how these communities of kind of radical spreaders actually work. So through social network analysis, which is, you know, methods of network science, we're able to do that, and we're doing that also within the project. And it becomes quite enriched when you couple it with text and analytics, which is kind of what we were talking about earlier. And then within these communities, what's also very, very vital for intelligence is understanding the interactions of these users. It's interesting to know who's kind of at the center of spreading the radical content, who's, you know, basically just kind of someone who amplifies, or who could be an actual threat. This is something that network analysis can help you do, but it is a big challenge. So what we see is that, you know, data science, all of these kind of techniques are an ally to overcoming all of these challenges faced by the traditional tools that are in the hands of LEAs these days. And our answer to that as a consortium is basically, it's the Red Alert Project. So the main goals of the project, as Monica got into a little bit earlier, is that we want to develop and test a real-time system to identify terrorist and radical content. And we're doing that by kind of summarizing large amounts of data, and we're doing that through AI. And what we want to do on a very basic level is automate the identification aspect of investigations, identification and understanding aspect of investigations for LEAs. So the scientific pillars of the project, I've alluded to a little bit earlier. So, you know, when we look at NLP, natural language processing, that's what we use to help basically our models understand the way humans are writing and what actually is relevant and what is not relevant. Social network analysis, as I mentioned before, which is represented by our partners, Maven 7 and ELTE from Hungary. Basically what their models do is map out the relationships and flows and kind of interactions between the users and the organizations on the internet. So, and we're doing all of this obviously coupled with, you know, machine learning and deep learning. Talking again about the methods that we're using. So, you know, we have methods that are based on messages. So, you know, the natural language processing models, machine learning models, which are basically enabling us to detect content, suspicious content, radical content based on the text. And then based on the community, as I mentioned before, this is important for detecting links, you know, between criminal or radical groups, how they interact, how the users interact with each other, how they're grouped together. And then there's some other methods, like, for instance, behavioral information, basically things that the author of some of the messages do on the different social network platforms or internet sites. So the scientific approach, this is very simplified, but basically we wanted to combine, the AI methods with social network analysis and NLP technologies, and to detect some anomalies in the content. So, we're looking at the type of content, whether it's suspicious, if people are retweeting, links to suspicious users, these types of things. And all of these things are then fed into a complex event processing engine, which is supplied by our partner ICE. And what it does is it's basically creating pattern detection. So when this type of content is produced, or these types of user interactions happen, the LEA end user will receive an alert and be able to visualize this on the user interface. And this is a very simplified version of basically what we're doing. We're intaking the data, we're analyzing it on the one hand with NLP, and then we're analyzing the relationships within the social network analysis models on the other side, putting it into the engine, and then doing, basically prediction, data mining and prediction of threats in order to have early detection capabilities. This is what the technical architecture looks like. So it's more or less kind of what you just saw, but you can see here that we add in, for instance, here some rules. Talking about rules, one thing that's really important to this project is the implication of the LEAs who are involved in the project. Some of them I think are on the call today. Basically, without LEAs and without also the knowledge of ICT in terms of terrorist-related content, we wouldn't be able to feed our learning system with the right intelligence that comes from actual human beings to teach the artificial intelligence to be accurate. So that's very, very important. So we're also really proud to have that sort of implication from law enforcement. So the outputs, the concrete outputs to LEAs are based on what all of the work that we've been doing over this 36-month project is, we want to be able to alert to suspicious content pointing to criminal behavior. We want to be able to derive user information based on the analysis that our AI is performing. We want to understand the relationships between the users. And we also want to learn to alert to trending information, because obviously, as already pointed out, detecting the threat kind of before it happens is the important aspect of everything that we do in these types of projects. And in terms of the benefits to law enforcement, we want to automate investigative tasks, because obviously, there is a lot of data to be dealt with by LEAs on a daily basis. And we want to do this because there are basically tasks that are impossible to perform on such massive amounts of data, especially when you're talking about multiple platforms, hundreds of thousands of messages per hour, lots of different sort of user interactions happening at the same time. It's really, really hard, especially with LEAs being strapped for resources. It's hard to have these analysis capabilities just with human beings. So we want to help them in that sense. Also unearthing the content that would basically go undetected. So sometimes, as I mentioned before, tools don't have AI built into them, and basically what the tools that are being used are doing are just looking for keywords. So what Red Alert is looking to do is basically, unearth information without having to kind of look for it. Also a better understanding of the radical communities via the social network analysis that I mentioned earlier. And of course, early warning alerts in order to be more proactive in the face of threats. So that's all I have for you today. I'd be happy to take any questions that you guys have. Thank you so much.
Thank you very much, Jennifer. And now we will have the end users, Yaniv.
Good afternoon. Thank you, Yuri. Thank you, Monica, and thank you, Jennifer. Even though every time I speak after Jennifer, I realize I have nothing to add, almost nothing to add. So thank you, Jennifer. It was excellent, actually.
Thank you.
I want to elaborate a little bit about the aspects from the law enforcement. Let me share slides. Can you see the presentation?
Perfect.
Okay, Great. I want to start with a case study, that of terror activity that was posted online in 2014. A terrorist opened fire on security forces in Jerusalem with an improvised weapon called Gustav. And before that, before he took that action, he actually revealed on his Facebook page that a lot of comments regarding other terrorist attacks, and also really several hours before the attack, he posted 2 remarks about him gonna be a shaheed. That's a very good example for the entire need of a project like Red Alert, because this kind of case we see all the time. We see a lot of terror activity, not just terror, also criminal activity going online. And the problem is we still after that is actually finding that. The second level of this problem is actually, okay, before that, what we do see online is actually everything. We mentioned part of that, but we see the recruiting, we see the propaganda, we see the public support. They're even looking for public support, and you can see the public support also in the comment, in the social media, in open webs. You see the online communication, the operational synchronization. Sometimes it's coded with keywords or something, but you can see it. And of course, also the financing and money laundering and all the reconnaissance that these terror groups are actually doing. A lot of this data, is on the open web, not just on the darknet, not just on secure channels, but also on the open web. What we can see now, and this is the second level of the problem, you can see here, it's a different case that we had. It's a case of someone who was calling what we call the SWAT calls. He was calling and reporting bombs in different places, whether it's airplanes, schools, community centers. And after gathering a lot of information from the internet, we managed to build his profile. A lot of this is missing. This is another challenge that we have especially when we're handling criminals over the internet. We know a lot about them, but we still don't know many things are missing. We still don't know who he is, where he is, and other important things. So this is another level of the challenge, okay? Because the challenge is actually, first of all, we want to know as much as possible and as early as possible. And of course, we have privacy in front of us, and that's what actually our need to balance between the possibility to read, to get to know everything and keep people's privacy. But to know as much as possible and early as possible, it's important, because if you have a Facebook comment, a Facebook post, like I showed in the first example, of someone glorifying him going to be a shaheed, and he posted that just a few hours before he opened fire, that means that you really need to take it on real time. Getting the alert a day after, or even getting it technically into the system and just waiting for a human analysis to be processed, sometimes it's too late. You really need it real time, early as possible, in order to take action in the right time. So as Jennifer and Nuri also mentioned, but our main challenge is that the data is, first of all, out there. I showed you some example of a lot of information that is out there, whether it's the recruiting, the public support, the personal comments, pictures sometimes a lot of guides, okay? There's a lot of guidance for the new members in terror activity, how to do things, whether it's how to build bombs, where to do their activity, how to disguise themselves, how to get away from the intelligence forces, how to hide the evidence. A lot of information is out there, whether it's on the social network, digital forensic, even online digital forensics, and in other channels of cyber intelligence. we need actually to get this data, to get the alerts, but also what we need is not just finding the data, but also to understand it. Because the volumes are high, you have a lot of information. We need not just to find the needle in the haystack, but also to understand, is that a needle? Where is it pointing at? And what are they going to do with it? The haystack, as you can see, is the social media, is all other intelligence sources, but we need to know many things. First of all, as I said, we need to get the alerts. Not less important, we need to have the link analysis between all the data, and sometimes if you take a look at very small portions of the information that you can find online, you don't get the entire picture. Some of them look innocent, some of them look legit. I can see a post talking about some religious ceremonies that is about to happen, another post about using old tools, and another post, for example, glorifying myself, religion's new state and everything. But when you combine it all with other information that you can find, you can understand and get the pattern that something is going to happen, something that is not legit, something that may lead to a terror activity. And we had a lot of examples like that. Unfortunately, in Israel, we had a time that a lot of stabbing incident, terror activity was taking place. And that was very hard to find out, because most of these incidents happened by what we call the lonely attacker. They were not related to any official terror organization. They were influenced from online propaganda, but they took the action by themselves, and getting all the information that led them to take this step and do the activity is something that is very hard to know. So you need to get the alert, you need to get the link analysis, but you also need to filter out a lot of irrelevant data, because you have a mass information. You need to filter out the irrelevant data, and then you have to enrich all this data with all other information that you have. Not all of the information is coming from online gathering, but sometimes some are coming from other intelligence information systems, inside information system, and other sources. You need to enrich it all to get the full picture. Jennifer talked about actually how the technical solution is going to happen, and for us the solution is exactly what Red Alert is coming in to solve: enhanced data analysis tools, whether it's the artificial intelligence, the NLP, the social network analysis, and other complex processing of the data from the event, from the different sources. And the main thing is actually getting the alerts. And that's what Red Alert is bringing for us, the real-time detection, which, as I said, is very important. The alerts in real time is very important, and especially if we can make the predefined alerts of what we need, the pattern that we are looking for, whether it's terror activity, crime trends, or any other indicator. The data mining and analysis, but also for us as a law enforcement, it's very important to use all this information to post-event investigation, whether it's a close post-event or later post-event, because sometimes when terror activity is happening, you need to know more. You need to find out about other entities that are related to the incidents that we are investigating. We need to track other actors. We need to find the financial course of all the funders for this activity. We need to know a lot of, first of all, to get the evidence and to really understand what happened there. Second, to prevent any secondary actions. And of course, to get the entire intelligence situation. What you can see here, most of it is in pictures, but these are actual photos that and comments that were posted online in the social media. On the left side, you can see someone who is showing himself before he's going to take terror activity against armed forces. Another one is before actually committing a stabbing incident in Jerusalem. But the third example is actually, it's a little bit different from the entire terror activities that we were talking about, but is also can be very useful with a system like Red Alert. And this is something that us as police in the cyber unit, we faced a lot. It's actually, it's a very good example for a pattern that we have defined and we are very interested in, and actually is happening a lot. It's actually a post of someone posted his intention to commit suicide. Okay, his intention to commit suicide, and we see that a lot, and you see a lot of many respond to this kind of post. Sometimes they alert the police by phone or anything, but sometimes they don't. Whether it's been posted in a forum in a foreign country that they don't know how to contact the local police, or for any other reason, it was posted late at night. The exposure was just the day after. And we also need the ability to get alert on that. So one of the uses that we are going to do with a system like Red Alert that actually we can define what we are interested in and to get the alert is this kind. And this is, by the way, a real post. I'll translate it from Hebrew because most of our cases are in Hebrew. That's why you don't see the text of the other post, but this is a real post of someone who just informed that he's about to commit a suicide, and all the other person saw this one, really were worried. They called the police, but also we managed to get the alert even before we were notified by phone. These are the example, very critical example, why we need this kind of alerts. Any questions so far? I'm here.
Thank you very much, Yaniv. Thank you very much. The demo is 18 minutes. It's quite long and quite detailed. So I'm not sure that everybody is interesting, but we would like to show it to those of you that are interested in it. So if no more questions, yes.
This is the Red Alert portal. There are 4 types of users that can access the portal. They are coordinator, analyst, super user, and administrator. First, a user of type coordinator will log into the portal. The coordinator oversees a team of analysts whom receives tasks from him. After the coordinator logs into the portal, he has several options available. First, the coordinator will see the dashboard, where the status of the case files that were assigned to his team of analysts or to himself in the last month is displayed. He can also see the case files assigned to him or to the members of his team. He can filter by several criteria or sort them. He can also see some charts regarding these case files. The coordinator can add a new chart. Several types of charts are available for different information in a case file. In this new chart, the user can see the types of case files. How many of type evaluation, investigation, or surveillance exist. The coordinator can also access the statistics menu. This page displays information about the online and offline data that was collected by the system. Also, there are charts displaying when the collected data was posted and when it was collected. The user can filter by case file or a case task, by the period of time data was posted or the period the data was collected. If he selects a case file, he will only see the data collected by tasks associated with that case file. The coordinator can also see the alerts detected by the system. They can be filtered or ordered by several criteria. There is also a history tab for older alerts. Other options that the coordinator has are using the data visualization component, importing several offline files, changing the language of the portal, and managing his account. Now, the coordinator will access the case menu. This menu is used to manage the case files and tasks, to assign them to analysts that are responsible to collect and analyze the data. In short terms, this is the menu that collects the data used by the rest of the system. A case file is used to group the information and actions needed to be done by the team for a new analysis of a subject of interest. First, the coordinator will create a case file. In order to create a case file, all mandatory fields need to be filled. These fields are marked with red. The user can choose a priority, a case type, or a classification level. All these fields can be changed by the administrator. More options can be added if needed. A name and a short description of the case file can be added. At the end, the Save button needs to be pressed. The case file with identifier 187 was created. The coordinator can filter by that identifier and the new case file will be displayed. A case file can have several case tasks of different types associated with it. More analysts can work on a single case if the coordinator assigns them tasks. A case task can have several types. File association for offline data collection. Online data collection to crawl data from different social media networks. Classifier training to add, if needed, new classifiers to the NLP component of the system. And de-anonymization. All the data that is collected into the system is anonymized. So, for example, if it's needed to find out who a user really is, a new de-anonymization task must be created and the coordinator can approve it or deny it. Only if the coordinator considers that de-anonymization is needed based on the information collected, the analyst will see the real data. In Red Alert, the confidentiality of the data is very important and additional steps and approvals are needed to access the real data by anyone. First, a file association type case task will be created. All the mandatory fields must be filled. The coordinator will assign this case task to an analyst in his team or to himself. Next, an online data collection task will be created. All the mandatory fields marked with red must be filled. The coordinator can assign this task to himself or to an analyst in his team. Next, the coordinator type user will sign out and the analyst type will log in to start showing how to import, crawl, or analyze the data. The analyst has the same options as the coordinator, but in the dashboard and the case files and case task menus, he will only see the ones assigned to him. He can order or filter by different criteria. This is the new case file that the coordinator created. The analyst first will access the online data collection task. The analyst can select one social network or several social networks to collect data from. For this demo, all will be selected. The available networks are Facebook, Instagram, OKRU, Telegram, Twitter, vContacts, and YouTube. A classifier for the NLP component can be chosen, or all of them can be used. If needed, more classifiers can be added. Next, some keywords for search must be added. A combination of keywords can also be used. The analyst can select on the map the area from where the post must be collected from. In order to start the crawling, the task must be saved. To start the crawling, two options are available. The task can be edited again and the user will press the Start button, or the crawling can be started from the Online Data Collection session menu. Here, all the online data collection sessions from the online data collection tasks are displayed. In this case, the task the analyst configured before. The analyst can enable it and crawling will start. The crawling has started. The analyst can disable it temporarily and enable it after some time. It can also be purged, meaning the data will remain in the system, but the crawling session will no longer be available anymore to clear system's resources. Or it can be deleted. In the Statistics menu, the user can filter by the case file, and only the data collected by tasks of that case file will be displayed. The crawling task already collected 3 tweets. The analyst can also import offline data that he has from other sources, using a case task of file association type. Here, he can upload different files like images, videos, JSON files in a certain preset format. The analyst will import an image and a video. Next, he will press the Save button and start work. In the Process Steps tab page, the user can see the steps that those 2 files are going through. These steps are the same ones that each post that is collected from social media goes through also. These steps are: first, string parsing and data enrichment. Data enrichment is only for media files. For example, in the videos and in the picture, the SMA tool detects different types of objects and the confidentiality of being that type of object. If the video has sound, the speech-to-text option of the SMA tool will translate the speech to text. After that, the data filter is applied and the data privacy. All the usernames and confidential information are anonymized, and only after they will be stored in the system's databases. Next, the information goes to the 2 NLP components of the system. All these steps are displayed for each file that was uploaded. The analyst can see the status they are in, when they started and finished, and the responses from corresponding components. The previous uploaded image is a young boy with a gun. The response from the data enrichment contains a frontal face that was detected and the confidence of almost 1 that is a person in the image. For the movie, the response from data enrichment contains a profile face, guns, and so on. To import larger files, the analyst accesses the Import menu. This is an example of a very simple file. In the production environment, this kind of files will have thousands of rows and more complex data. Next, the user chooses the file to upload and presses the Upload button. He can see in the History tab all the imported files and their status. The file just uploaded is in processing, and the user can also see some logs. The number of posts is 4, and the process instances were created. The analyst can access the Statistics menu and see there are already imported 3 offline posts and 27 from Twitter. The analyst will access the Alerts menu. This is how Alerts page looks like. When the system detects an alert based on a configuration the analyst created, it will be shown here. Alerts can be filtered or ordered. These are the last alerts. To configure an alert, the analyst will access the Alerts configuration menu. Here are displayed all the applications already configured to detect alerts. the user will create a new one. If the case file is added, only the data from that case file will be used. If not, the data from all the existing case files will be used. The analyst must add two sets of keywords. For the demo purpose, a very simple alert will be added, using the keywords bomb and attack. The application was created and the user can see it here. Before he can run it, at least one rule must be added. Several combinations are available, including the type object detected in the media files. A simple one will be created now, where the probability of being a bomb is very low. The user can run the application, but before, he can also view or change the config file where several options are available and the keywords files. In the keywords files, he will see the keywords he added and some synonyms for them. The second keywords file also contains synonyms for attack. The analyst will start the application by pressing Run. In the statistics page, the user can see that more posts were collected. Also, the offline import is finished. In order to trigger an alert, the user needs to transfer the data to the CEP component. This is done by pressing Mongo to Kafka transfer option. This option must be pressed from time to time to add new collected data that pass over a threshold. For the demo purpose, a very low value will be chosen to trigger an alert. Usually, this is a long-running process and will take some time, depending on the amount of the existing data. Already, a new alert has been detected. The analysts go into the alert menu and order them descending by the creation date. There is an alert detected from the data collected on another case file, but with the alert configuration that was just created. The alert details can't be accessed. The keywords that fired this alert were bomb and miss from the first file and strike from the second file. Strike is a synonym for attack, the user added in the configuration. The media links from the posts that trigger the alert and the posts themselves are displayed. The user can also see the reason that triggered the alert. The data displayed is anonymized and looks like this. Several alerts can be detected by the system later based on this configuration. In the statistics page, the number of posts collected continue to rise. The analyst can access the data visualization menu. Here, he will select the new case file just added and the time period for the data he wants to view. He submits the search and needs to wait until the status is completed. For this case file, there are 108 nodes and 49 links. First, the user will retrieve the results. If any of the collected posts have geolocation information, here a world map will be displayed with points for the origin of the posts in the search. Unfortunately, they are none. Next, the user will press Post to S&A component. This component will analyze the nodes and the links using different algorithms. The results can be seen here. There is a network map. All this can be seen in full screen mode for a better view. Each node has the post associated. The analyst can also see the links between the users. Next, the analyst can see the predicted edges using different prediction algorithms. Here, the temporal communities and how they evolve over a period of time can be seen. Because the data for these case files was scrolled for a short time, we won't see something here. The analyst can also use another visualization tool for the alerts. He can go into the alert configuration menu and access the Grafana component, where different information about the alerts are displayed, like the keywords, the posts, and the graphical representation of the time frame with different colors for different users that triggered the alerts. This was a short demo of the capabilities of the Red Alert system. Thank you for your time.
Thank you for the speakers. Thank you for the participants. And hope to see all of you face to face soon. Have a good night.